day, grade 12 learners. Welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Now for today's knowledge area, we'll be focusing on mechanics, which has a total of 93 marks. And today's topic will be on momentum, which is question 3 and consists of plus minus 21 marks in your examination for paper 1. So now just to remind you, with the mark allocation for paper 1, we have section A, which consists of 10 multiple choice questions and has 20 marks. And then you'll also have either 8 matching items or 1 word items, which has a total of 8 marks. We also have section B, which consists of structured or long questions and consists of 122 marks. And the total for the paper will therefore be 150 marks with a duration of 3 hours. Again, just to remind you on the content that we will be covering for paper 1, we are going to be covering mechanics, which has a total of 93 marks and the percentage weighting of 62% there. Electricity and magnetism, which has a total of 33 marks and a percentage weighting of 22. And then wave, sound and light, which has a total of 24 marks and a percentage weighting of 16. Okay, so so far now we have covered momentum, and then we said momentum of an object is the product of its mass and the velocity. We have covered the units for both the mass. We said it's kilograms, and the units for what? For velocity, we said it's what? Meters per second. And then we also covered the SI units for momentum. We said it's going to be a combination of what? Of the mass and the velocity, and of which the mass is what? Is the kilograms and the velocity is meters per second. So those are the units of what? Of momentum. And then we also said momentum is a vector, thus the direction is what? Is important. Remember we said a vector is what? It's a physical quantity which has both magnitude and direction. So again, we said momentum of an object depends on what? On the mass and the what? And the velocity. So we said in terms of the relationship, if you increase the mass, the momentum will also increase. If you increase the velocity, the momentum will also what? Will also increase. So we said in terms of the relationship, both the mass and the velocity, they are directly proportional to the what? To the momentum. And then so far we also covered the what? The change in the momentum. We said it is the difference between the final momentum and the what? And the initial. So the difference between the final momentum and the initial momentum. And then we also said the change in momentum is a vector quantity. Vector quantity, which means it's a what? It's a physical quantity which has both magnitude and what? And direction. And then we said the change in momentum is dependent on the change in the velocity. We spoke about the SI units for the change in momentum, and then we said the SI units will be the same as that of the momentum. And what is the units of momentum? Units of momentum, remember we said it's kilograms meters per second. So therefore the units also of change in momentum is what? Is kilograms meters per second. And then again, we spoke about the formula of the change in momentum, P final minus P initial. Or we can also say change in momentum is equals to M times change in V. Change in V is what? Is the change in the velocity. And then we also said that we can also write it in this way to say change in P is equals to M into brackets VF minus V initial. So far we have not done the law of conservation of what? Of linear momentum. That is what we are going to be covering. And then we also covered Newton's second law in terms of linear momentum. which says the net resultant force acting on an object is equal to the rate of change of momentum of the object in the direction of the what? In the direction of the net force. So it says the net force acting on an object. So the net force is what? Is F net, that is acting on an object, is equal to the rate. So when we said when we speak about the rate, then we are speaking about what? We are speaking about the time. So it's equal to the rate of what? Of the change. There's the change of momentum on top of the formula then of the object in the direction of the what? Of the net force. And then we also spoke about impulse. It says impulse is the product of the net force and the time and is equal to the change in what? Is equal to the change in momentum. So we said the product means that you are dealing with what? You are dealing with multiplication. So the product of what? So multiplication of what? Of the net force and the what? And the time. And then it says here impulse is the product of the net force and time and is equal to the what? To the change in momentum. So it says here impulse is a vector quantity and the direction is what? The direction is important. Okay. Then remember also, whenever you are doing your calculations, whether you are doing your homework or you are in the examination, you need to use your formula sheet and you need to know exactly which formulas you have to use for that particular topic. So when it comes to your formula sheet here, you are going to need this one, which is P is equals to mv. You are going to need this one as well for impulse. This one is for what? Is for your momentum, and this one is for what? Is for the change in momentum. Okay, then just to remind you on this one, it says you need to define impulse as the product of the net force. So define impulse as the product of the net force acting on an object and the time the net force acts on the object. So again, we said when we speak of the word product, then we are speaking about what? Multiplication. So product of what? Of the net force. So the multiplication of the net force acting on an object and the what? And the time. There is your change in time. The net force acts on the object. Then we said impulse is equal to what? Is equal to the change in what? Change in momentum. So impulse is what? It's the F net. Remember the product of the net force and what? And time. It's therefore equal to what? It's therefore equal to the change in momentum. So according to the formula as well. Then it says use the impulse momentum theory. So impulse momentum, there's your impulse on the left hand side, momentum is on the right hand side. So use the impulse momentum theory to calculate the force exerted. So we need to use this formula to calculate what? The force exerted, that's your F net. The time for which the force is exerted, that is your change in time. And the change in momentum, this one, change in P, for a variety of situations involving the motion of an object in one dimension in the context of technology. Then it says you need to explain how the concept of impulse applies to road safety considerations in everyday life. For example, airbags, seat belts, crumple zone, and also what? Arrestor baits. We will explain that later. Then it says impulse is the product of the net force acting on an object and the time the net force acts on the object. Okay. Therefore, impulse is F net times change in time. And then according to the impulse momentum theory again, F net change in time is equals to what? Change in P. Therefore, it says the net force acting on an object. This one, the net force acting on an object is equal to the what? To the rate, which is your change in time of the what? To the rate of momentum, rate of change of, to the rate of change of momentum of the what? Of the object. Then again it says F net is the rate of change of the momentum of the object. Okay, so that was just to remind you on that one. Then it says impulse is a vector quantity We said vector quantity is what? A physical quantity which has both magnitude and what? And direction. What is the magnitude? Magnitude is the size. And then it says, and its SI unit is Newton second. Newton second, not Newton per second, but Newton second. Then it says, note that when calculating the change in momentum, the SI units would be those of momentum. And then still remember what the SI units of momentum are. The SI units of momentum are what? Kilograms, meters per second. So for momentum is kilograms and then what? Meters per second. But then it says an impulse will have the same value as the object's change in momentum, but with a different SI unit. Okay? So if, let's say, we calculated the momentum, and then maybe our answer for that momentum is what? Is maybe 40 kilograms meters per second. If the question now says calculate the impulse, then what would the units be in terms of impulse? It says an impulse will have the same value as the object's change in momentum. So an impulse will have the same value, so meaning we will have the same value as what? As 40 there, but with what? With a different SI unit. So what is the SI unit of impulse? The SI unit of impulse is what? Is Newton what? Newton second. So remember we said, where is it coming from? The Newton is coming from the F net, and then the second is coming from the change in time. Okay, so if you are calculating the momentum, this would be your units for momentum. But if you are calculating the impulse, this would be your units for what? For impulse. Then on this example here, it says a 0.53 kilogram basketball hits a wall head-on with a forward speed of 18 meters per second. It rebounds with a speed of 135 meters per second. The contact time is 0.1 seconds. Okay, so now let us read so that we can be able to collect the data. So it says a 0.5 kilogram basketball, and then 0.5 in this case, what is it representing? It is representing the mass. So it hits a wall head on. So this ball is hitting a wall head on with a forward speed of 18 meters per second. So if this is the wall, this ball is hitting a wall with a forward speed of what? Of 18 meters per second. So that would be our initial what? Velocity. And then it rebounds. So rebounds, then it means what? It's going to move in the opposite direction there. So that would be now our final what? Our final velocity. Then it says the contact time, so that one would represent our change in time there. And the contact time is what? Is 0.1 seconds. Okay, so it means that whenever we have this kind of a problem, then we need to identify or first find the direction. So we are going to decide on the initial direction of motion as what? As positive. So it says with the forward speed, so I'm going to take the forward speed as to the right, and then I'm going to give whatever that is going to the right, I'm going to indicate that it is going to be positive. And then whatever that is going in the opposite direction or to the left, I'm going to indicate that as what? As negative. So the one that's rebounding is our final velocity, and it is in the opposite direction. of the initial movement of the basketball. So it says calculate the impulse of the force exerted by the wall on the basketball. So what are we going to do there? We'll say F net change in time is equals to what? Is equals to the change in momentum, right? Because remember we said impulse is equals to what? Is equals to the change in momentum. So from there we need to F net change in time is equals to what? M V final minus V what? V initial. So F net change in time, remember what does it represent? It represents the impulse. The question is saying that we need to calculate the what? We need to calculate the impulse. So we have already collected the data. We said that we have the mass, which is what? Which is 0.53. We have the final velocity, which is what? We said it's moving to the left, and whatever that is moving to the left, in terms of direction, we said that we are going to take that direction as what? As negative. So the final velocity will therefore be negative 135 minus, what is the initial velocity? Our initial velocity was 18 meters per second to the right. So we leave that as positive 18. But remember the formula already had a negative. That's why it's negative 135 minus what? Minus 18. So therefore F net change in time, which is what? Which is the impulse, is equals to, so from there you are going to punch that into your calculator. Minus 135 minus what? Minus 18. Minus 18, it's minus 153 multiplied by 0.53, which then gives me, let me just recalculate this quickly just to make sure. Minus 135 minus 18 minus 153 multiplied by 0.53, so it's giving me negative 81. Negative 81, negative 81, 09. So now what's important? The question said that we need to calculate the what? It said that we need to calculate the impulse. So in this case, what would the impulse be? It's negative 81, 09. But remember we said that the units of impulse is not going to be kilograms meters per second, but then the units of impulse would then be what? Newton what? Newton second, right? And then again, remember that we are not going to leave our answer as what? As a negative. So after you have written the negative answer, you are then going to write it as a positive. So 81,09 Newton second. And then again, your direction in this case, since they did not give us east or to the right, we can then say our direction is what? Is going to be away from the wall. Away from the wall. It's either you say away from the wall, or because they said with the forward speed, maybe we can also say what? Backwards. So that's another option that you can use there. So to solve this, what did you do? You had to use your formula sheet. From there you had to collect the data. We didn't have anything to convert there. So from there we had to equate impulse to the what? To the change in momentum. And then we found the answer. That answer, we then gave it the units of what? Of impulse, because that's what the question asked. And then from there you gave your answer as positive and also gave the what? The direction there as well. And then why did we say away from the wall? Whatever that is positive will be described as what? As towards the wall. And then whatever that is negative will therefore be described as what? As away from the wall. Okay. Then B then says calculate the force of the wall on the ball. So now we need to calculate the force. Okay, so what are we going to do? F net change in time is equals to what? Is equals to change in P. So we already know that time, we said that time is what? Is 0.1 seconds. And then we have already calculated the change in momentum. And then now we can therefore be able to calculate the what? The net force or the force. So what are we going to do? We'll say F net is equals to change in P over what? Over the change in time. We have already calculated the change in momentum, so we are just going to substitute it. So it's negative 81.09 divided by what? Divided by the change in time, which is what? Which is 0.1 there. So you will then use your calculator and then divide the change in momentum with what? Divide the change in momentum with the 0.1. So I'm getting 810.9. And then what are the units of the net force? The units of the net force is therefore what? Is therefore Newton. But remember, we had a negative change in momentum. So therefore the net force will also be negative. And then from there, what are you going to do? You are going to write your answer as a positive. And then again, for your direction, we said towards the wall, we are going to take that as positive. And then anything that is away from the wall, we are therefore going to take it as what? As negative. So in this case, our answer is what? Is negative. Therefore, our direction will therefore be what? Away from the wall. Okay. So this one was just testing us on what? On calculation of the force. And then what did we use? You use the change in momentum that you had previously calculated. And then you also use the what? You also use the time that was given. You calculated your answer. It gave you a negative answer. So you therefore had to write it as what? As a positive answer. And then because a force is what? Is a vector, which means what? It's a physical quantity which has magnitude and what? And direction. So here's our magnitude. Magnitude is what? It's the size. Here's our SI unit, and this is the what? This is the direction. Okay. So for this one, learners, I'm going to give you about 3 minutes to do this one, and then we are going to do it together. So 3 minutes for this one. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. If you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. Okay, learners. So let's do this one together. So it says here, in a crash test, a 1,500 kilogram car. So let us collect the data as we read. In a crash test, a 1,500 kilogram car. So this would be representing the what? The mass. Traveling to the right with an initial velocity of 15 meters per second. So we are given direction and we can see that the car is traveling in which direction? It's traveling to the right with an initial velocity of 15 meters per second. So we are given the initial velocity of the car, it's 15 meters per second there. It collides with a wall and then it says it rebounds with a final velocity. So it then collides with this wall here. After colliding, what happens? The car rebounds with the velocity of what? So this line should actually be smaller, or let me increase this one. It rebounds with a final velocity, so VF of what? Of 2,5 meters per what? Per second there. Okay, so we have the mass, we have the initial direction, which was what? To the right. We have the initial velocity, which was 15 meters per second, and then rebounds means that we have the final velocity and also the direction. So 4.1.1 says you need to define the net force in terms of what? In terms of momentum. And for how many marks? For 2 marks there. So you're going to define it as the net or the resultant force is equal to the what? To the rate of change of what? Of momentum. So you define that for 2 marks. And remember, when you do your definitions, you need to define according to the examination guidelines. And then also with the definitions, you are either going to get 2 marks or what? Or nothing. And then 4.1.2 says you need to calculate the car's initial momentum. So how are we going to do that? Car's initial momentum. So we know that according to the formula sheet, momentum is equals to what? P is equals to mv. But in this case, we are calculating the what? The car's initial momentum. We can also write this as what? P what? P initial and V initial to indicate that we are calculating the what? The car's initial momentum. So what do we have in terms of the data that is collected? We have the mass, which is 1,500. It is given there. And then we also have the what? We also have the velocity. So let us then choose the direction. In this case, I'm going to choose the initial direction of motion as what? As positive. So the initial direction of motion was what? Was to the right. And we had an initial velocity of what? Of 15 meters per second. I'm going to choose that direction as what? As positive. And then if the right is positive, it means that the left will therefore be what? The left will therefore be negative. So it's 1,500 multiplied by what? Multiplied by 15 there. So you would then use your calculator to multiply the 1,500 with what? With the 15. And for this one, I'm getting 2250. And then remember, momentum is what? Is a vector. So you need to give it what? You need to write the magnitude as well as the direction. So the units of momentum, they are made from what? The mass, which is kilograms, meters per second, from what? From the velocity there. Okay, so in this case we said whatever that is positive, we're going to choose whatever answer that you get, or whatever that you have that is positive, the direction will therefore be what? To the right. So that will be the direction of what? Of the momentum. So this one is 3 marks. We're just going to give 1 mark for the formula, 1 mark for substitution there, and then 1 mark for the final answer with the correct SI unit and the correct what? And the correct direction. So you need to have both. You need to have the correct answer, the correct SI unit, and also the correct what? The correct direction. Okay, then so it's a continuation from here. 4.1.3, calculate the net force on the car if the collision lasts for 0.5 seconds. So how do we then calculate the net force? So we're going to use this formula. F net what? Change in time is equals to what? Is equals to the change in momentum. So in terms of the data that was collected there, what is it that we have? We are looking for this one, the net force. Yes, we do have the change in time, which is what? Which is 0.5 seconds there. But do we have the change in momentum? We don't have the change in momentum, but what is it that we have from the previous question? We have the initial momentum. Okay, so it means we'll have F net change in time is equals to what? MVF minus what? Minus MVI. So final momentum minus what? Minus the initial momentum. So from there, what are we going to do? So it will be F net. The time is given as what? The time is given as 0.5. The mass. So for the final, we said the velocity is in which direction? We said it's to the left because they said it does what? It rebounds. So meaning it will move in the opposite direction. So for the mass, we have 1,500 multiply by what? Multiply by negative 2.5 minus what? Minus the initial momentum, which was what from the previous question? It was 22,500. So from there it will be F net multiplied by the change in time is equals to, and then you are going to punch that into your calculator, multiply by negative 2.5. So for this one I'm getting negative 3,750 minus 2,250. Okay, so from there, what is it that you have? You have this 0.5 on the left hand side, and then you also need to solve the right hand side. So what are you going to do? It will be F net times the 0.5 is equals to negative 3,750 minus 2,250. So that then gives me negative 2,250. So from there, what are you left with? You are left with the 0.5 on the left hand side, and you need to get rid of the 0.5 on the left hand side. How are you going to get rid of the 0.5? You divide by 0.5 on both sides, right? So from there, what do you have? The 0.5 and the 0.5 are going to cancel each other out. And then what do you have? So I'm going to continue here. You will then have F net is equals to, you are going to divide this with what? With the 0.5, and it's going to give you negative 2,500 what? Newton. Okay, so remember, you are not going to leave your answer as what? As a negative. So what are you going to do? After you have then wrote your negative answer, you are going to write it as a positive answer, which is what? 5,500 Newton. But remember, the net force is a vector, so you are going to give it what? You are going to give it the direction. And what is your direction in this case? We said whatever that is going to the right will be positive, or whatever answer that we have as positive, we'll say the direction is what? Is to the right. And then whatever answer that we have as negative, we'll therefore say that the direction is what? Is to the left. Okay. So this one has a total of what? Has a total of 5 marks. So we'll then give 1 mark for the formula then, 1 mark for the substitution, 1 mark for the substitution again on the right, and then for the final mark there, we'll give for the correct answer with the correct what? SI unit, and the correct what? And the correct direction. Okay. Then the application of momentum, impulse, and change in momentum. So we have the use of what? The use of airbags. So just the airbag that you know in terms of what? Cars. It says modern cars use airbags as a protection system as shown in the figure. When the airbag inflates during the collision, the contact time of the passenger or the driver with an airbag is longer than without what? Than without an airbag. Then it says while the change in momentum remains the same, thus the net force on the passenger or the driver is reduced according to F net is equals to change in P divided by what? By change in time. So what are we saying? We are saying that if the what? If the change in momentum, so the change in momentum on this formula here, if the change in momentum remains the same, that is in terms of the scenario of the airbag. So if the change in momentum remains the same, then what happens? If you have an airbag, so let's say that you have what? You have collision. We are saying that if you have an airbag on a car, then you are going to have what? A longer contact time. So the change in time is going to increase as opposed to if you do not have what? You do not have an airbag. So we're saying if you have an airbag, then the contact time will be longer, right? So if the contact time is longer, then the net force will be what? The net force will be reduced. So it means that when it comes to injuries, in terms of what? Of collision, when you have a collision, when you have an airbag, the airbag will help the passenger to have what? To have a reduced net force. And then when they have a reduced net force, it means that in terms of the injuries as well, the passenger will have what? Will have less injuries, as opposed to if there is no what? There is no airbag, then what is going to happen? It means that you are going to have a shorter time. So if you have a shorter time, so a decrease in the time, and therefore you are going to have what? A much higher net force. So if you have a higher net force, it means that if you do not have an airbag and there's collision, you are more likely to have what? To have more injuries as opposed to somebody who has an airbag. Okay? And then we have what we call crumple zones. So the application of momentum, number 1 would be the use of airbags. Number 2 is then the crumple zone. It says everyday accidents take place on the roads of our country. Modern cars have a crumple zone to reduce the risk of death or injury during collision. The front of the car is designed to crumple during the front end collision as shown on the on the figure. So as shown where on this figure. So this portion of the car is called what? Is called a crumple zone. So when you have a collision, this portion of the car is meant to do what? To crumple. That is why it's called a crumple zone. Then it says when the car crumples during the collision with any other object, the time of contact between the objects and the car increases. So when it is busy crumpling, what happens? The time of contact increases, so according to this formula. And then while the change in momentum of the car remains constant, so if this one remains constant, as the car comes to a collision, the car will do what? It crumples. And then it says this effect decreases the what? It decreases the force exerted by the wall on the car, as alluded to by the what? By the equation. So again, if you have a crumple zone, number one, what will happen? The crumple zone will increase the time of what? Of contact. If the time of contact increases, what happens to the force? Then you will have a decrease in the force. And it means that what happens to the person in terms of injuries? It means that the person will therefore have what? Will therefore have less injuries. But that is provided what? Provided the change in momentum remains what? Remains constant. Okay? So application number 2 is what? Is crumple zone. And then application number 3 is what? Is seat belts. It says seat belts save thousands of lives. They increase the time of contact according to F net is equals to change in P over change in time. If the time of contact increases, the net force will decrease, and that will reduce what? The injuries. So again, with the seat belts, if you have a seat belt on during collision, we are saying that the seat belt will do what? It will increase the time of what? Of contact. It will therefore decrease the what? The net force. And then if you decrease the net force, what happens to the person who's inside the car? Then the person inside the car will then have what? Will then have less injuries. So that is application number 3. And then application number 4, we have arrestor beds. So arrestor beds you would normally find on the side or on the sides of what? Of highways. So this is an arrestor bed. It says the braking system of a large truck may overheat and fail. If this happens, the truck driver may drive the truck into an arrestor bed off the main road to stop the truck. So maybe this happens often, whereby even maybe cars, in this case, we are using what? We are using a truck. So it says it may happen that the truck may lose what? The truck may lose, it may happen that the truck, so it says if it happens that the truck driver may drive the truck into an arrestor bed of the, okay, so if maybe the truck driver, if maybe the truck overheats and then the brakes what? The brakes fail, then the truck driver is therefore able to drive way into the arrestor bed. It says an arrestor bed is a sand or gravel pathway. So this arrestor bed, it says it is made of what? Of sand or gravel pathway. Then it says provided that the change in momentum is constant, the arrestor bed increases the time of contact and decreases the force exerted on the truck so that the driver or the truck will have what? Will have less harm. So again, according to this formula, what are we saying about the arrestor beds? We are saying that if the brakes of the car of the truck fails, or maybe let's say if the truck starts to overheat and it needs a place to stop, then we are saying that the truck driver is going to drive way into the arrestor bed. And then what will the arrestor bed do? the arrestor bed will increase the time of contact. And then we are saying if the time of contact increases, what will happen to the net force? The net force will decrease. And then that is provided what? That is provided that the change in momentum remains constant. So if the net force decreases, what is going to happen in terms of injuries? We are saying that that is going to lead to less harm in terms of what? In terms of the passenger who is driving the truck. Okay, so this is now just a summary again. We have arrestor beds, and then in terms of application, we said we have the crumple zone. So we have a front crumple zone, and we also have a rear crumple zone. And then we also spoke about what? We also spoke about the airbags. We also spoke about what? The seat belts. So all of this is from which formula? F net is equals to change in P divided by what? By the change in time there. And then it says here the net force. So this one, the net force, is inversely proportional to the change in time that is for the same what? For the same change in momentum. So the net force is inversely proportional to the what? To the change in time that is for the same what? Change in momentum. So by this statement, what do we mean? It means that as the time increases, so as the time increases, then what are we expecting? Then we are saying that the F net will do what? The F net will decrease. Okay. Then next we have the conservation of linear momentum. So according to the examination guideline, you need to know the following. You need to explain what is meant by an isolated system in physics. It says an isolated system is one on which the net external force acting on the system is what? Is zero. Okay? So as an example of the external forces, we can have what? We can have friction and the applied force. So we need to know this definition. It says what? An isolated system is one in which the net external force acting on the system is zero. And then I said an example of the external force is what? Your friction, or what? Or the applied force. Then we need to, it says state the principle of conservation of linear momentum, which says the total linear momentum of an isolated system remains constant. Okay? Or is what? Or is conserved in what? In magnitude and what? In direction. So total momentum before. So according to this statement then, we are saying that the total momentum before a collision or an explosion would be equal to the total momentum before a collision, or what? I mean, would be equal to the total momentum after what? A collision or an explosion. Okay? So total momentum before, it would mean that you would be dealing with whatever mass that you have before a collision, and then you would also be dealing with whatever initial velocity you would be having in terms of object A and in terms of what? Of object B. Then the total momentum after a collision, it means that you would be dealing with the mass of the object after the collision, and the final what? And the final velocity, so F, of object A and the final velocity of what? Of object B, and the mass as well of the object B. Okay. Then as an example here, it says a ball A of mass 0.5 kilograms. So we are going to collect our data here. A ball A of mass 0.5 kilograms. So we can already see that this will then represent what? The mass is moving in an easterly direction at what? At 5 meters per second. So we have direction, and we can see that the direction is what? The direction there is east. So east, we can also think of it as what? As to the right, at a velocity of what? Of 5 meters per second. Then it says it collides with a stationary ball of mass 0.6 kilograms. After the collision, the velocity of the ball is 3 meters per second. So this one was supposed to be given as what? As to the right. Okay. So a ball of mass. So we have two balls. We have ball A, and then we also have what? We also have ball B. So it says ball A has a mass of what? Of 0.5 kilograms. Is moving in an easterly direction, so it is moving to the right with a velocity of what? Of 5 meters per second. It then collides with a stationary, so this is our initial what? Velocity. Then it says it collides with a stationary, so the initial velocity of the 0.6 kilogram ball was what? Was 0 meters per second. Why is it 0? Because they said what? It collides with a stationary ball. Remember, when it's stationary, it means that its velocity is what? Its velocity is 0. Then it says after the collision. So now after this collision, we have ball what? Ball B, which has a final velocity of what? Of 3 meters per what? Of 3 meters per second, and it's moving in which direction? It's going to be moving to the right. Now it says calculate the total momentum of the ball before what? Before the collision. Okay. So the total momentum of the car before the collision. Okay. So I'm just going to give you about 2 minutes, and then we are going to continue and do it together. So 2 minutes on this one, then we'll continue and do it together. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. Okay, so let us continue here. It says you calculate the total momentum of the ball before what? Before the collision. Okay, so we can also write this as the sum of the momentum what? Before the collision, okay, is equals to what? Will be equals to the momentum of object A plus by the momentum of what? Of object B. So before the collision, momentum is represented by what? By mvi plus by mv what? mvi as well, but this is for object A, and then this one would be for object what? For object B. Okay, so we are given the mass there of 0.5. So we are going to substitute that 0.5. And then what is the initial velocity? The initial velocity of object A is 5 meters per second. It's moving in which direction? It's moving to the right. So we are going to take the initial direction of motion as what? As positive. In this case, the initial direction of motion is to the what? Is to the right. So we are going to take the right as positive. So that means that the 5 would then be a positive 5, and then plus by the mass of object B is what? Is 0.6, and then the initial velocity of object B is given by what? Remember they said it collides with a stationary ball. This was when? This was initially. So initially the velocity for object B is what? Is 0. Why is it 0? Because they said the ball is stationary. Stationary means what? There is no movement. No movement would mean that the velocity is what? The velocity is equals to 0. Okay, so from here what are we saying? We are saying you can then calculate the 0.6 multiplied by the 0. 0.6 multiplied by 0 is going to give you what? Is going to give you 0. So it means that you can just multiply this one, which is what? 0.5 multiplied by 5, and that would give you 2.5 what? It said the total momentum, right? So here we said the sum of the momentum before, so it means the total momentum of PA and of PB before, that is what we're calculating. So because they said momentum, then we know that the units of momentum would be what? Would be kilograms, and then what? Meters per what? Per second. Okay, so we said that if we have a positive answer or for whatever that is going to the right, our direction will therefore be what? Our direction for a positive answer will be to the right. Okay, so we have a positive answer there, so therefore the direction will be to the right. Okay, then it says the velocity, so the next question, the velocity of ball A after the collision by making use of the law of conservation of what? Of momentum. Okay, and then so remember we had the initial velocity of ball A, which was what? 5 meters per second. We had the initial velocity of what? We had the initial velocity of ball B, which was 0, because we said it's stationary. And then after the collision, we only had the final velocity of what? Of B. And then now the question says that we need to calculate the what? The velocity of ball A, using what? By making use of the law of conservation of what? Of momentum. So remember it said what? the total momentum. So the total momentum before would be equal to the total momentum what? After. So the previous question, it was saying that calculate the total momentum of the ball before what? Before the collision. So we're not going to repeat that. We just calculated that way on question number 1 there. So the total momentum before, we said it is going to be what? 2,5. So from there it means that we then need to calculate what? The total momentum after. So the total momentum after would then be from PA final plus by P of B what? Final. So from there, what are we saying? MVF of A plus by MVF of what? Of B is equals to what? We have the mass of what? Of ball A, which is 0,5 there. And then what is the final velocity of ball A? That is what we need to calculate. And then what is the mass of ball B? The mass of ball B is given by what? By 0,6 there. What is the final velocity of ball B? We said this is 3 meters per second. In which direction? To the right. So we said if it's to the right, whatever velocity or answer that we get, if it's to the right, then we are going to take that as what? As positive. So it's 0,6 multiplied by the final velocity there, which is what? Which is a 3. So on the left hand side here, we have a 2,5 and a 2,5. That is coming from where? From the total momentum of the ball where? Before the collision. So we have 2,5 is equals to 0,5 final velocity of object A is equals to, so we're going to multiply the 0,3 multiplied by 3 into your calculator there, and then you'll see that it gives you what? The 1,8. Okay, so from there, what is it that we need to do? We need to transpose, right? So we have 1,8 and a 2,5. So what will be easier to do? It will be easier to take the 1,8 where? To the other side. So when you take it to the other side, you are then going to say 2,5 minus 1,8. What does it give you? It gives you a 0,7, which is equals to 0,5 VF of A. So from there, what is it that you are going to do? We can see that we have a 0,5 and the final velocity of A there. So what are you going to do? You need to get rid of the 0,5. So you are going to divide both sides by what? By 0,5. And then what happens? The 0,5 and the 0,5 will do what? They will cancel each other out. And then what are you left with on the left hand side? You are left with 0,7 divided by what? By 0,5. So you would then use your calculator to calculate the 0,7 divided by 0,5, and on my side I'm getting 1,4 meters per what? Meters per second. And then in this case, we know that velocity is a vector, which means that it is a physical quantity which has both magnitude and what? And direction. Okay, so we said that whatever that we are going to have as positive or to the right, whatever that we are going to have as a positive answer, our direction for that will therefore be what? To the right. But if our answer in this case was what? Was negative, then our direction will therefore be where? To the left. Okay, so our velocity, our final velocity for object A will therefore be where? In which direction? It will therefore be to the right. Okay, then elastic and inelastic collision. It says use the conservation of momentum to solve problems involving momentum in the context of technology, and then restrict problems to 2 objects moving in 1 dimension along a straight line with the aid and appropriate sign convention. So this is just in terms of the examination guidelines, and with what you need to know in terms of the examination guidelines, it says you need to distinguish between what? Elastic collusion and inelastic collusion. That is using what? Using word statements, and also using the calculations there. Okay. So for an elastic collusion, it says it is a collusion where the total kinetic energy remains constant. A collusion where the total kinetic energy remains constant. Okay, so remember that kinetic energy is given by the formula EK is equals to what? Half mv squared, right? Whereby EK is representing the kinetic energy, and then M is representing the mass in kilograms, and then the V would be representing the what? Would be representing the velocity. Okay, so it says a collusion where the total kinetic energy remains constant, and the total momentum and the total kinetic energy are conserved. So with an elastic collusion, using this formula, we are saying the total kinetic energy before is equal to the total kinetic energy after. And then we said that the kinetic energy is given by this formula, which is EK is equals to half mv squared. So we are therefore saying the total kinetic energy, that is from where? From object A. So this is our object A. So before, again, it would mean that we have an initial velocity there, and then of object A and of object B. So initial, and then the total is equals to the total kinetic energy after a collusion. So it means that on the right hand side, we would be looking at the kinetic energy of object A, that is after. So that would be representing what? The final velocity. And then also this one, total kinetic energy after, would be representing the final velocity of what? Of object B. Okay, so just to repeat, when it comes to elastic collusion, we are saying that the total kinetic energy before a collusion would be equal to the total kinetic energy after a collusion. Okay, but we are saying that the total momentum is conserved. So meaning that the total momentum again before the collusion would be equal to the total momentum after a collusion. That is with an elastic collusion. But with an elastic collusion, we are saying a collusion where the total kinetic energy is not conserved and the momentum is conserved. Okay, so with an elastic collusion, we are saying that according to the formula again, the total kinetic energy before the collusion, now with an inelastic, we are saying is not will not be equal to the what? To the total kinetic energy after the collusion. But then what are we saying? In terms of an inelastic collusion, we are saying that the total momentum before the collusion would be equal to the total momentum after the collusion. So then it means that what is the difference between the elastic collusion and the inelastic collusion? The difference would be the total kinetic energy. For an inelastic collusion, the total kinetic energy before the collusion is equal to the total kinetic energy after the collusion. But then for an inelastic collusion, we are saying the total kinetic energy before the collusion is not equal to the total kinetic energy after the collusion. But then what is the same for both of them? For both of them, we are saying that the momentum is conserved, meaning that the total momentum before the collision for both of them is equal to the total momentum after the collision for both of them. Then it says the sum of the kinetic energies of the objects. So the sum of the kinetic energies of the object. So the sum, it means that we are going to be adding what? The kinetic energy before the collision. It says would be exactly equal to the sum of the kinetic energy of the objects after the collision. So by sum, it means that we are going to be adding the total kinetic energy of object A and of object B before the collision. We are going to add it, and then we are also saying that whatever that we have before the collision would be equal to the total kinetic energy what? After the collision. Then it says it occurs when the colliding objects stick together upon impact. So for an inelastic collision, we are saying as an example, after a collision, we are saying that the two objects would then what? Would then stick together. So let's say we had object A, and so object A, and we also had what? We also had object B. So we are saying that after the collision, and then with an inelastic collision, we are saying that the objects would then stick together. Okay, and then let us have a look at this example here. It says a ball A of 40 grams is moving to the right at 2 meters per second. It collides with ball B, which has a mass of 50 grams. So let us just collect the data. So we have ball A, which has a mass of what? Of 40 grams, is moving to the right. So this ball is moving to the right. Let us just indicate it there with a velocity of 2 meters per second. It collides with ball B, and then so this is ball B, which has a mass of what? Of 50 grams, moving in the opposite direction at 3 meters per second. Okay, so in the opposite direction, our initial velocity there is what? Is 3 meters per second. After the collision, the velocity of ball A is what? Is 2.5 meters per second to the left. Okay, so initially we had 2 meters per second for ball A, and then initially we are saying our mass is what? Is 40 grams. And then again, we are saying for ball B, we have what? We have 50 grams there. And then we are saying that our initial velocity for ball B is what? Is 2 meters per second. Now another scenario, after the collision, what happens? The velocity, so this is ball A, the velocity of ball A is what? Is 2.5 meters per second. In which direction? To the what? To the left. So what is it that we are going to have there? That is our final velocity for ball A. Let me write A, and what? And B. Our final velocity is 2.5 what? Meters per second. Okay. In which direction? To the left, and that is why my arrow is facing where? To the left. Calculate the velocity of ball B after what? After the collision. Okay, so I'm going to give you about 3 minutes to do this one, and then we are going to do it together. So 3 minutes for this one, then we will do it together. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. If you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. Okay, so let us go back to the question here. So it was saying calculate the velocity of what? Of ball B after the collision. So what are we going to do? We can then say the sum of the momentum what? Before the collision is equal to the sum of the momentum after the collision. Okay, so before the collision we have PA initial plus PA. We have P of A and P of B initial. That would be equal to P of A final plus by P of B what? Final. So from there, the initial momentum for A would be given by what? By MV initial for A plus by MV initial for B. Then after the collision, what do we have? We have MV final of A plus by MV final of what? Of B. Okay, so now as for the mass, we are given the mass of A as what? As 40 grams, and then we are also given the mass of B as what? As 50 grams. So remember, then it means that we need to we will need to do what? We will need to convert the grams into the kilograms. So how are we going to do that? You are going to have a 40. So for ball A, you will then say 40 divided by what? Divided by 1,000, and that would then give you what? 0,004, and that is 0,04. What are your units? Your units would then be kilograms. And then for the 50, you would do the same. 50 divided by 1,000 would give you 0,05 what? Kilograms. So now we are ready to substitute. Okay, so what is the mass of ball A? The mass of ball A, we said it's going to be 0,04. What is the initial velocity of ball A? The initial velocity of ball A, we said it's going to be 2. And is it going to be a positive or a negative 2? It's going to be a positive, because we are going to take whatever direction that is going to the right as what? As positive. So we are then going to have a positive 2 there, plus by the mass of ball B. We said it's going to be 0,05. And then from there, what is the initial velocity of ball B? We said the initial velocity of ball B would be 3 meters per second. And then here we said that ball B is moving in which direction initially? It's moving to the left. So we said we are going to take the right as what? As positive. If the right is positive, then it means that the left is what? Is negative. Okay, so for ball B, then we are going to have what? A negative 3 there. And then after the collision, then what happens? The mass of ball A is given as what? Is 0,04 multiplied by the final velocity of what? The final velocity of object A. It said that after the collision, the velocity of the ball is what? Of ball A is 2,5 meters per second to the left. So we said whatever that will be going where? To the left. We are going to take the direction as what? As negative. So it means that we'll have a negative here, 2, what? Negative 2,5. Maybe we can put that inside the brackets. We'll have a negative 2,5 plus by what is the mass of object B? The mass of object B is given by 0,05 multiplied by. Remember the question said that we needed to calculate the what? we needed to calculate the velocity of ball B after the collision. So from there we are going to have the velocity, or the final velocity of ball B after the collision. Okay, so from there, what are you going to do? You are going to take your calculator, and then you can then multiply whatever that you have on the left hand side and multiply whatever that you have on the right hand side. So 0.04 multiplied by 2, what is it? It's going to give you 0.08. And then from there you have, maybe if I also put this one inside the bracket, 0.5 multiplied by -3. And then what does it give us there? It gives us negative what? 1.5 is equals to, on the right hand side, what do you have? You have 0.04 multiplied by negative what? Negative 2.5, and that would give you a negative what? 0.1 plus by 0.05 times final velocity of what? Of object B. Okay, so from there, what are you going to do? On the left hand side, you have a 0.08 minus what? Minus 1.5. So you would then punch that into your calculator, and your left hand side would therefore give you what? Negative 1.42. And then on the right hand side, you still have what? Negative 0.1 plus by 0.05 times the final velocity of object B. So from there, what is it that you can do? You can then transpose this one. You'll have negative 1.42 plus by 0.1, and then on the right hand side you are left with the final velocity of what? Of object B. So you will then punch that into your calculator, negative 1.42 plus by 0.1, and that would then give you what? Negative what? 1.32, which is equals to what? 0.05, and that would be the final velocity of what? Of object B. Yeah, that would be the final velocity of what? Of ball B. So from there, what is it that you can do? From there, you have 0.05. So you can therefore divide both sides by the 0.05. So on the right hand side, it's 0.05 divided by 0.05, and your final velocity will therefore be given by, so you can then punch that into your calculator, and then my final velocity, this side, it gives me a negative 26.4 meters per what? Meters per second. So we are therefore going to say final velocity for B is given as 26.4 meters per second. And then what would be the direction in this case? Whatever that is going to be negative, whatever that is positive, we said it's going, the direction will be to the what? To the right. So whatever that we have as a negative answer, our direction will therefore be to the what? To the left. Okay. So this would then represent what? It would then represent the velocity of ball B after what? After the collision. Okay. Then number 2, determine by making use of calculation whether the collision was elastic or what? Or inelastic. So what are we going to do? We're going to say that the sum of the kinetic energy before, remember, we are not going to equate it because we are not sure if it's going to be elastic or what? Or inelastic. Okay, so the sum of the kinetic energy before is equal to what? Is equal to EK of what? Of A plus by the EK of what? Of B. So let me just write it here. So the EK of A the EK of A would be equal to what? To half MVF of A initial plus by half MV B what? Initial squared. Okay, so from there, what is it that we need according to the formula? We are going to need the mass of object A before the collision. We are going to need the initial velocity of object A before the collision, the mass of object B before the collision, and the velocity of object object B before the collision. So what is it that we have? We have half. What was the mass of object A? We said it's 0,4. When we converted the 40 grams, we said 40 divided by 1,000, and then it gave us what? The 0,04 there. And then we said that when we converted this one, the 50 grams, it gave us what? 0,04. Okay, so we have the mass there, and then we said what is the initial velocity of ball A? We said it's 2, so it's going to be 2 squared plus by half of 0,05. That would be the mass of what? Of object B, multiplied by what was the initial velocity of object B. So the initial velocity of object B, it was given as what? As a 3, so -3 what? Squared. And then with that, we would then calculate the kinetic energy before. Then from there, you would then take your calculator and then you multiply what? The 0,4 multiplied by the 2 squared there. All of that multiplied by 0,5. So that would then give us 0,8 what? 0,8 joules. When you are done, you can then calculate the sum of the kinetic energy what? After the collision. What is it given by? EK of A plus by EK of what? Of B. So the EK of A would be given by half MVF squared plus by half MVF squared for object A and for object what? For object B. So from there you'd have half of what? Of 0,4 multiplied by what is your final velocity for object A? We said it's -2,5 because they said it moved to the left there, plus by half of 0, what? Sorry, this one is 0,04, this one is 0,05. Okay, all what? All squared there. And then from there, so this is the mass, and then we'd have to find the what? The velocity of object B, and of which it was what? It was in the previous question. And then what did we find for that velocity? We said it's 26,4. So we would then substitute that 26,4 all what? All squared. Okay, so from there you take your calculator, 2,5 all squared multiplied by 0,4 multiplied by 0,5. So this part is 0,125, and for this part we would then say 26,4 all squared multiplied by 0,05 multiplied by 0,5. So this part would give you 17,42 there. So from there you would add the 2, 0,125. So this one would give you an 8,84 joules. Okay, let me just confirm the one on the left hand side there. So we said 2 squared times 0,04 multiplied by 0,5. Okay, so the first part there, the first part here was 0,08 plus by Then we said 3 squared times 0.05 times 0.5. So the second part, we would then add it to the first part. So it would be 0.08 plus 0.225, which would then give us a 0.305. Sorry about that, learners. So the kinetic energy, the sum of the kinetic energy before the collision would give us 0.305, and then the sum of the kinetic energy after the collision would give us an 8.84. So remember we said that if we have an inelastic collision, it means that the total kinetic energy before the collision would not be equal to the total kinetic energy after the collision. So in this case, before the collision we have 0.305, and then after the collision we have an 8.84. So the question was saying that we needed to determine whether the collision was elastic or inelastic. So it means that in this case, our collision would therefore be inelastic. Why? Because we are saying that the total kinetic energy before the collision is not equal to the total kinetic energy after the collision. Okay. So with that, learners, I will leave you with the words of Nelson Mandela, which says, "It is in your hands to create a better world for all who live in it." Thank you very much, learners. I will see you next time at the same place and also at the same time. Goodbye for now.